into the extraordinary universe of Exam Infinity, where the ordinary transforms into the extraordinary. I am Rajat Sharma, and this is NEET Sureshot series. Glue yourself onto your seat and watch the entire video, because this video will take you one step closer to becoming a doctor. So today is day 2 of our NEET Sureshot series, and today we are going to start with the first chapter, basic concept of chemistry, stoichiometry, and mole concept. All these things you will be learning today. So last class I told you about the entire periodic table. We learned the whole periodic table. We learned about the groups, the vertical columns are called the groups, and the horizontal rows are called the periods. Then we learned about the different elements. We learned about that the atom contains in middle of the atom is the nucleus, and in nucleus whatever is present is called the nucleons. So whatever is present in the nucleus is the protons and the neutrons, and the total number of protons and neutrons is the atomic mass, and the total number of only protons is the atomic number, and you represent atomic number bottom of the element, and the mass number comes on the top of the element when you represent an element. So today we are going to learn about what is relative atomic mass. Even this relative atomic mass is nothing but the total number of nucleons. Whatever I'm telling you until now, the mass of an atom, that is nothing but relative atomic mass. The total number of nucleons, protons and neutrons, that is called relative atomic mass. And how did we get that? We get that by mass of one atom of an element. What is actual mass of one atom of an element? Okay, so it will be very tiny number. Actual mass of one atom of element will be very small. It will be 1.67 into 10 power minus 24 gram for hydrogen. Like that you will have different masses. So 10 power minus 24 means you can think that it will have so many 0.000000000000000 23 times you will write 0, then you will write 167. So it's very small number, very very tiny number when you measure in grams. When you measure it in grams, it becomes very tiny. That's why we have this relative atomic mass. Okay, so to make the number little easier for us, we divide the mass of one atom of an element by 1/12th of the mass of one carbon. So we chose carbon, and we took 1/12th of the mass of carbon. So carbon mass, for example, is 12. So 1/12 is like 1 gram, like that. So whatever it is, 1/12th of the mass of 1 gram of carbon. So carbon mass will actually be 12 into 1.67 into 10 power minus 24 gram. Here when you take 1/12, so the 12 gets cancelled, and then you get this number. Okay, so that's what is happening. Then when you divide the mass of an atom, you get a whole number basically. So to get a whole number, we want whole number relative atomic mass. We don't want decimal, right? That's why we are dividing it by 1/12th of the mass of one carbon. Next, what is atomicity? So you have seen hydrogen, you have seen oxygen, right? Hydrogen is what? It's an element. Oxygen, element oxygen. But what is hydrogen gas? Whenever I tell you hydrogen gas, write the structure of hydrogen gas, you will write H2. Hydrogen is generally written as H2. Hydrogen gas is H2. Oxygen is O2. Chlorine gas is Cl2. So here the 2 represents the atomicity. Total number of atoms in a molecule is called atomicity. So H is element hydrogen, whereas H2 is molecule hydrogen. And molecule hydrogen will always have 2 atoms in it. 2 atoms of hydrogen join together to make a molecule of hydrogen gas, and that's why the atomicity of hydrogen is 2, because it's always found in 2 pair. So this is about atomicity, like H2SO4. I told you about hydrogen is H2 and chlorine atomicity will be 2. But what about H2SO4? How many atoms does H2SO4 have? 2 atoms of hydrogen, 1 atom of sulfur, 4 atoms of oxygen. So total how many atoms? 7. 2 plus 1, 3. 3 plus 4 is 7. So that makes atomicity of H2SO4 7. Now we will be starting mole concept. What is mole concept? Most of you have gone to a shop and you go to the store and you buy, say, bananas or eggs. When you buy eggs or bananas, you tell the shopkeeper that I want a dozen of banana or I want a dozen of egg. So when you tell the shopkeeper a dozen, what does he mean? Whenever you tell him dozen means 12, right? If you tell dozen of banana, he will give you 12 bananas. If you tell dozen of egg, he will give you 12 egg. If you tell dozen of chocolates, he will give you 12 chocolates. So dozen means 12. Like that, in chemistry, mole means 6.022 into 10 power 23. Whenever you have the word mole, 1 mole means 1 dozen, like how you had there, similar to that. Here it is 6.022 into 10 power 23. It's a very huge number. Here 1 mole is not 12, like a dozen. 1 mole is 6.022 into 10 power 23. So you can see there, how many zeros will come? 6 followed by 23 zeros. 6.022 followed by 20 zeros. 0, 0, 0, 0, 0, 0, 0. That's a very large number. If you talk in terms of 1 mole of banana or 1 mole of egg, if you wanted, it will cover the entire globe. Entire earth will get filled up with that. And still, the space will not be sufficient. So the entire, so very large number, very, very large number, okay? So because 1 mole of atoms are very tiny, right? So 1 mole of atoms will have this much atoms in it, or molecules in it, or ions in it. So that is called 1 mole. And this number 6.022 into 10 power 23 was given by Avogadro, so we call it as Avogadro's number, okay? So 1 mole contains Avogadro number or Na. Na means Avogadro number. N means number. Below that, if you write subscript A, it means Avogadro's number. Avogadro was the person who gave this number. That's why we tell it as Avogadro's number. So 1 mole contains Avogadro number of atoms, molecules or ions. Okay. Now how do you convert anything to a mole? How many mole is something? I give you 6.022 into 10 power 23 atoms. Okay, let's assume it's 6 for now. 6 into 10 power 23 atoms or molecules. Then I tell you how many moles it is. You will tell me 1 mole. How did you tell me it is 1 mole? Because you divided it by 6. Right? Because 1 mole contains that much. So if I have 6, means you divide it by 6 and then you get 1, which is 1 mole. If I tell you 12, into 10 power 23, what will you do? You will divide it by 6 into 10 power 23, which becomes 2. Then you get 2 mole, right? 12 will be double of it. 12 is nothing but double, right? So it's 2 mole. If I tell you 18, then it will be 3 mole. If I tell you 21, into 10 power 23 molecules. Into 10 power 23 is there after everything. So that much will be 3 mole. So like that. So how are you finding out? If I want to convert number to mole, number of atoms or something, whatever I give you number, if you want to convert that to how much mole it is, you are dividing it by Avogadro's number, right? You will divide it by 6.022 into 10 power 23. You will divide by that to get the mole. And if I give you 1 mole, 1 mole contains how many atoms? You will tell me 6.02 into 10 power 23. If I tell you 2 moles, you will tell me 12. How did you get 12 here? You multiply it by 2. 6 into 2 into 10 power 23, right? So you are multiplying the mole by number of atoms. 2 mole means you multiply 2 with Avogadro number. 3 mole means you multiply 3 with Avogadro number. Then you will get the total number of atoms or molecules. Same thing. If I give you a mass now, instead of number of atoms or molecules, I am giving you the mass of something. Okay. So when I give you mass of the compound that I have, if you divide it by molecular weight or atomic weight, say I have 1 gram. If I divide 1 gram of hydrogen, so I need to divide by 1 gram because the molecular weight of atomic weight of hydrogen is 1 gram. 1 gram of hydrogen atoms, okay, not molecules I'm not talking about now. So if I divide it by 1, I will get 1 mole, right? But when it comes to hydrogen gas, it is 2 gram. So I can divide by 2 gram. So it is half mole. Molecular weight is 2, right, for hydrogen, because 2 molecules of hydrogen are present. So it's half mole, like that. So when you want to convert it to mole, what do? You divide by the molecular weight or atomic weight. And same way, if you want to convert mole to mass, you multiply the molecular weight or atomic weight. You will multiply with the mole. Okay. Now, these two are the formulas which are there for every situation. Now, only for gases. When it comes to gas, okay, when it comes to gases, STP, standard temperature and pressure, okay, when we talk about gases at STP, you multiply by 22.4 or divide by 22.4. If you want to convert mole to volume of gas, I have 1 mole of gas. That means how much volume of gas do I have? 22.4 liter of gas I have. Okay. So 22.4 liter of gas is 1 mole. And when I divide it by 22.4, it becomes, I can convert it to mole. So if I have 44.8 liter of gas, I will divide it by 22.4 liter, I get 2 moles, right? So 44.8 is 2 mole. So like that. If you want to convert volume of gas to mole, you divide. And if you want to convert mole to volume of gas, you multiply. Everywhere this is the situation. And this entire thing, like a Y it is forming, right? This is Y map of mole. You need to remember this. In one map, easily the entire mole concept can be understood. by all of you. Okay, and what is STP? Volume of gas at STP, I told you, right? Only at standard temperature and pressure. Remember, this is applying. So standard temperature and pressure means 273.15 degree Kelvin, 273.15 Kelvin. I'm sorry, degree doesn't come for Kelvin, it comes for Celsius and Fahrenheit. 273.15 Kelvin, and pressure is 1 atmosphere. Okay, and temperature is 273.15 Kelvin, pressure is 1 atmosphere, volume is 22.4 liter. It will be present volume. Okay, so remember, pressure is 1 atmosphere and temperature is 273.15 Kelvin at this temperature. Next, you have density. So you learned about density in physics also, right? So density is nothing but mass by volume. All of you know. Say 1 liter of some substance will, per liter of something, has how much mass? That is its density, right? Like that. So mass, when you divide by volume, you get the density. Now, when you studied about density, you have density compared with water. You generally compare the density of something with density of water because you want to find whether something will float or sink, right, in water. So you are seeing the density with respect to water. In that situation, it was called specific gravity. How much of gravity will act on something, right? If more gravity will act on it, it will sink. Less is acting, it will float. So that is called specific gravity. So in case of specific gravity, it is the density of the substance divided by the density of water at 4 degrees Celsius. This is the formula of specific gravity. And for gases, we don't talk about specific density because we are not talking about sinking or floating. Here we are going to talk about absolute density. There we learned about what is specific gravity before some time. Now it is absolute density. In density only you have specific gravity. Okay, specific gravity is a density only. Density's ratio with water density. Okay, so will it have any unit? Because density of a substance divided by density of water, both are density. So density will get cancelled. So specific gravity doesn't have any density, right? Next you have absolute density. Absolute density is for gases. It is nothing but mass by volume. But here it is molar mass by molar volume. Okay, molar mass of gas divided by molar volume of the gas. Molar volume of the gas. Okay. Next, you can also write it as density is equal to Pm by RT. Okay, because you know the formula PV is equal to nRT.
So ideal gas equation is PV is equal to nRT, and all of you know that. So PV is equal to nRT. You have N, we converted to number of moles, which is mass by molar mass, and from there you can see the density we have separated. Okay, and next you have vapor density. Just like what you studied specific gravity, density of substance you compared with density of water, right? Like that, vapor density is density of gas compared to density of gas, that is hydrogen gas. Okay, there you compared with water, density of substance by density of water. Here you are comparing density of gas by density of hydrogen gas. So will this have a unit? No, right? This will also not have a unit because this is density by density. One density you are comparing with other density. So it's the ratio of density of gas by density of hydrogen, right? Hydrogen gas. So here you can write density of gas as Pm of gas divided by RT whole divided by Pm of hydrogen divided by RT. Right? Pm of gas by RT upon Pm of hydrogen by RT. Right? You can write that. Then here pressure will be same because both the gases are kept in same pressure. The pressure is same for both gases. So Pp you can cancel. And R, can you cancel R? R is same because it's a constant. R will be same everywhere. Temperature you can cancel because temperature will be same. So you are left with mass of gas by mass of hydrogen gas, and mass of gas by 2, right? Hydrogen gas molar mass is 2. So you get mass of gas divided by 2. That is how vapor density formula comes. Okay, vapor density is mass of gas by 2. Okay, so this formula most of you might be knowing. Vapor density is mass of gas by 2. But from where did it start? Vapor density actually means density of gas by density of hydrogen. Okay, it's not mass of gas by 2, it's density of gas by density of hydrogen. From there we have derived it to be mass of gas by 2. Or you can write mass of gas will be 2 times of its vapor density. Okay, so this is the density. In density all these we learned. Okay, so until now we learned what is relative atomic mass, mass of one atom of element by 1 by 12th of mass of one carbon. Atomic mass we learnt, atomic mass into 1.67 into 10 power minus 24 gram. If you multiply both atomic mass and 1.67 into 10 power minus 24, you get actual mass. Then we learnt about atomicity, that is total number of atoms in a molecule. Then you learnt about mole. In mole concept we learnt about how to convert number to mole. Number into Na, Avogadro's number will give us, divided by Na gives us mole, and multiply, you can convert mole to number, and divide mole volume of gas by 22.4, you get mole, or you divide the mass by 22, or you divide the mass by molecular mass or atomic mass, you get mole. Then we learned about density, the third concept. So we learned about mass, we learned about mole, we learned about density. In density, we learned about specific gravity, which is density of substance by density of water. Then we learned for gases. Then we learned about vapor density. Then we learned about mass of a gas is 2 times of vapor density. Now we will be learning about concentration terms. What are these concentration terms? Concentration means, all of you might be knowing, having an idea. Whenever you talk about concentration, you tell how concentrated something is. You have seen, right? Concentrated sugar syrup, concentrated salt solution, concentrated milk, dilute milk, you might have seen, right? So this milk is very much diluted, it's mixed with water. That means the milk is less in that. Per liter, if you buy milk packet, in that the quantity of milk is less, but quantity of water is more. In 1 liter of milk, milk itself is less, but water is more. So that is how you measure concentration, right? So per liter, how much of that substance is added? Some substance. That is called concentration, right? That is one way of telling concentration, right? So 1 liter of water, if I have added 1 kg of salt, then it's very concentrated, right? In just 1 liter of water, 1 kg entire packet of salt is there. So it's a very concentrated salt solution. That's the same thing if I do 1 spoon of salt in 1 liter of water, it's less concentrated, right? So these are concentration. So what is solute and what is solvent from here, you can understand. In what you are dissolving something. In water, I dissolved milk. So here the solvent was water and milk is the solute. What is getting mixed? What is getting mixed is the solute, and inside what it is getting mixed, that is called the solvent. Okay, so in water, something is getting mixed. So water is the solvent. And what is getting mixed? Salt is getting mixed. So salt is the solute. Okay, so how do you measure concentration now? There are different ways. One, I just told you just now, how much of solute is dissolvent, how much of solvent. But that how much can be measured in different ways, right? What does how much means? How much can be grams, it can be liter. I can measure some grams, I can measure how much in terms of liter, right? Molarity is number of moles of substance by volume of solution in liter. Okay, number of moles of substance divided by volume of solution in liter is molarity. If you find the moles, if you have 1 mole of salt in say 1 liter of solution, the molarity is 1. Okay, like that. So weight by molecular weight, weight by molecular weight of solute is number of moles, right? So weight by molecular weight into 1000 I will multiply, because I need to divide the volume by 1000 to convert it to ml from liter. So the 1000 comes to numerator. Now you have weight of substance into 1000 divided by molecular weight into volume of solution in ml. So that way I converted the the molarity from moles to weight. In the formula now you have weight ultimately. Nothing we have done, we have just written number of moles in the form of weight. Okay, next you have molality. Now molality is nothing but number of moles of solute. How much mole of solute we are dissolving in how much kg of solvent. Okay, here the solvent is measured in kg. In molarity it was volume. In molality, la, okay, there it was riti, here it is liti. Okay, li, L for molality. So there you have number of moles of solute by mass of solvent in kg. Now you want to convert kg to gram, so you multiply it by 1000. Same thing what you did there. And if you want to convert number of moles to weight, then you can write weight of solute by mass of solvent. Okay, so you get molar mass of solvent. So 1000 into W1 by molar mass, right? So that is how that formula came. 1000 into W1 by molar mass into W2 weight of solvent. Okay, W1 by M1 is nothing but moles, and W2 mass of solvent, your it's there in the denominator, right? So like that you got it. Next, mole fraction. Mole fraction is nothing but it's fraction. From the word itself you can hear. So number of moles by total moles. So it's the fraction of moles. There is no kg, there is no volume now. Now everything is moles. So in the numerator you have moles of one particular thing. It can be moles of solute divided by moles of solute plus solvent. That is mole fraction of solute. Mole fraction of solvent will be moles of solvent divided by total moles. And if you add both the mole fraction x1 and x2, so different solutes can be there. If you have different solutes will have different mole fraction. So now if you add both, you will get 1. So if you add the mole fraction of everything that you have, you get mole fraction as 1. Okay, total. Next, you can also measure the concentration in percentage, right? So you have percentage weight by weight. It's very easy. Mass of solute by mass of solution, weight by volume, percentage if you want to find, weight of solute by volume of solution, percentage volume by volume, so volume of solution by volume of solute by volume of solution, right? So in the numerator you have solute everywhere. Numerator will always be solute. Even there you studied number of moles of solute, number of moles of solute by volume of solution in kg or volume of solution in liters. So you studied, right, in molarity and molality. Now you have percentage weight by weight, weight of solute by weight of solution, weight of solute by volume of solution, that is percentage weight by volume, volume by volume, volume of solution by volume of solute by volume of solution. That is the thing. And because it's percentage, you multiply all by 100. It's clear, right? Because it is percentage, you need to multiply everything by 100. Next, you have few other formulas, okay, related to this only. Whatever you learned until now, similar to these, you have few other formulas. So they are mole fraction into molarity. I want to find molarity. Okay, I gave you the formula for molarity, right? But how do you find molarity if I know mole fraction? I know mole fraction, but I want to find molarity. Okay, so then the formula is molarity will be equal to mole fraction into density of that substance. Okay, mole fraction into density into 1000 divided by x1 mi mole fraction into molarity plus m2 x2. Okay, here it's molarity. Mole fraction you're converting to molarity, right? So here m1 m2 is mass, you know that. So x1 m1 plus m2 x2. Next you have molarity into mole fraction. So I want to find mole fraction from molarity. So again it is nothing but m1 molarity into mass of one first compound into 1000 divided by density into 1000 minus molarity into m2. m1 m2 are the masses. Okay, next you have mole fraction to molality. So molality will be what? Molality is equal to x2 mole fraction of second component into 1000 divided by x1 m1. Molality into mole fraction, that is x2, is equal to m molality into mass of first compound divided by 1000 plus molality into m1. Next molality into molarity. So molarity, if you want to find from molality, it's molality into density into 1000 by 1000 plus molality into mass of second compound. Molarity into molarity is mass is equal to molarity into 1000 by 1000 density minus m2. If all of you comment down below, then I will upload even the derivation of all these. If you want how the formulas have come, I will upload the derivation of all the important formulas here, whatever is important. Otherwise you can just by heart the formulas, because I feel it's not required. Learning the density derivation and wasting the time will not be required, because you don't need the derivation to solve in the exam. But still, if you want it, because it will help in some questions. So if you want that, how the formulas have come, if you want to know it, comment down below. I will definitely make a video on that also. But now let's not waste time in learning the derivation, because I want the video to be helpful for all, not just the students who want to learn extra. So if somebody wants anything extra, you can comment below, then I will make video on those extra things separately. But because derivations are not important, they are just extra for your extra knowledge, you need to comment down, okay, if you want them. Next, what is average or mean atomic mass? So all of you saw in the periodic table, if you see the atomic mass of different elements, you might have seen that atomic masses of different elements are given in decimal. But I told you atomic masses are whole number, right? It's not decimal. You have a normal number. Integers it is. So you will have 1, 2, 3. That is how atomic masses have to be, right? 1, 4. You learn for hydrogen it's 1, for helium it's 4. But if you see for hydrogen, you will see that the atomic mass is 1.0045, like that. Some decimal is given. Why is it like that? Because the masses that is given in the periodic table is not the atomic mass. It's the average or mean atomic mass. And now what is mean atomic mass or average atomic mass? So mass is given by A, okay? Mean atomic mass or average atomic mass is written by A. So A of any compound is nothing but atomic mass into the percentage abundance. And now what is this percentage abundance? There are different isotopes, right? For every atom there will be isotope. Isotope is nothing but the same atom has different atomic masses, okay? Because same hydrogen will have hydrogen with no proton, with no neutron, with 1 neutron, with 2 neutron, right? You can have protium, deuterium, tritium, like that. Different types of hydrogen are there. All are hydrogen. All those are hydrogen because number of proton is same. Protons decide what element it is. But neutrons also contribute to mass number. So if there are more neutrons in an atom, its mass will be more. If there are less neutrons, its mass will be less. So every atom has 2-3 different varieties of that atom. with different number of neutrons. So, but how do you get mass then? If same hydrogen has different atomic masses, which atomic mass is the real one? So to find that, which is more percentage abundant, which hydrogen, which type of hydrogen is found in nature more, in what percentage it is found, that is called percentage abundance. Okay, so say for example, protium is found 97%, 95% of the all the hydrogen in nature is protium. For example, I'm just giving example. If that is the case, then percentage abundance of protium is 95. Deuterium is just 2%. Tritium is just 3%. Like that. So you have different percentages, right? So then, including all those, you find the average of all the three. That is called the average atomic mass, and that is what is given in the periodic table. Okay, so how did they get it? They multiply the atomic mass into percentage abundance plus atomic mass of second compound into percentage abundance of that plus atomic mass of third isotope into percentage of that. So protium into the percentage abundance of protium plus deuterium into percentage abundance of deuterium plus tritium into percentage abundance of tritium. When you add all these, you get the numerator and you divide that by 100, then you get the average atomic mass that is given in the periodic table as 1.00 something. Okay, so this is what is mean. This is what average atomic mass or mean atomic mass. Same way you have mean molar or mean molecular mass, which is nothing but N1 M1 plus N2 M2 plus N3 M3, like that, so on, divided by N1 plus N2 plus N3, like that, all you will add up. Okay, that is called the mean molar or molecular mass. Now you have Dulong-Pettit law. He said that atomic mass is 6.4 divided by specific heat. Okay, this is Dulong-Pettit's law. He said that when you find atomic mass with specific heat of any substance, you need to divide 6.4 by the specific heat of that. You will get the atomic mass. Okay. Now Avogadro, he said that Avogadro's law, he said that equal volume of gases, of all gases, if you take equal volume, contain equal number of molecules at same temperature and pressure. Okay, if the temperature is same, if the pressure is same, then the volume of all the gases is also same if it is same. Okay, if the volume of all gases is same and the temperature is same and the pressure is same, then the number of molecules will be same. That is what you learned, 22.4 liter of any gas, that is the volume of any gas, at that will have same number of atoms or molecules, right? 6.022 into 10 power 23 at same temperature and same pressure. That was the number of molecules. So here you can see H2 plus Cl2 is 2 HCl. It will give you 2 hydro HCl, right? If you are reacting hydrogen and chlorine and you are making hydrochloric acid, so 1 ml of hydrogen, 1 ml of Cl, both will be 1 ml because both are at same temperature and pressure. Now what is oxidation number? Number of electrons in valence shell is called oxidation number. Okay, I showed you yesterday the structure of the atom. So in the structure of the atom, you saw electrons were revolving around it. Okay, so there is last shell is called the valence shell. Okay, last shell will be called the valence shell. In that valence shell, how many number of electrons you have after number of electrons in valence shell, and if you subtract it by number of electrons left after bonding, after the bond is formed between two atoms, that is called the oxidation number. Okay, number of electrons in the valence shell minus number of electrons left after bonding is called the oxidation number. So different atoms have different oxidation number. This I will explain you in detail all these things in the further classes, but for now, for doing questions, because you may require all these things, so I have given it. Okay, but in the detail you will learn in the respective chapters. But in this chapter I'm just telling you the formulas for few concepts. So whatever I'm telling you the formulas in this chapter, in future you will be learning them in detail, so don't worry. Next, concept of equivalent weight or mass. Equivalent weight is nothing but atomic weight by valency factor. Okay, so equivalent weight is atomic weight by valency factor. Remember this formula. And equivalent weight for acid or basis, molecular weight by basicity or acidity. And this is the thing. Okay, you have molar mass by number of moles of electron gained or lost. So equivalent weight is atomic or molecular weight by valency factor. Remember this, it's important. Okay, valency factor will be given to you, or you need to know how many hydrogen it can accept, release, all those things I will tell you in detail. But for now, remember this formula. Concept of number of equivalent. What is number of equivalent? Number of equivalent of a solute is weight by equivalent weight. When you divide the weight of something by its equivalent weight, you get the number of equivalent of solute. Okay, this is required for normality. Normality is number of equivalent of solute by volume of solution in liter. How you had molarity? Molarity was number of moles of solute by volume of solution in liter, right? Like that you have normality, number of equivalents of solute by number of volume of solution in liter. So molarity will be molarity into valency factor, okay? Molarity into valency factor. So how do you calculate valency factor? So valency factor is basicity or number of hydrogen ions furnished per molecule of acid. If there is acid, what is number of hydrogen ions furnished by that? And if there is base, how many OH ions are furnished by that? So at equivalent point N1 V1 is equal to N2 V2, which is N1 M1 V1 N2 M2 V2, okay? Because molarity into valency factor you learned, normality into volume, normality of second one into volume of second one, all that. Measurement of hardness now. What is hardness? It is measured in ppm, parts per million, okay? So hardness is water. If it is having certain salts, it is called hard water or soft water. So if how much of calcium carbonate is present in this one, mass of calcium carbonate by total mass of water, if you do, and if you multiply by 10 power 6, because million, right, parts per million, so mass of calcium carbonate divided by total mass of water into 10 power 6 will give you the hardness of water. Then you have different laws of conservation of mass. In law of conservation of mass, nothing, it's very simple. The total mass of a substance in reaction will be conserved, right? Because the mass will not get destroyed. Mass can neither be created nor be destroyed. So that is law of conservation of mass, okay? Then you have law of constant proportion, law of multiple proportion. Law of constant proportion tells us that in any part of the world, you bring any same sample, if you bring water from any part of the world, the ratio of their atoms is in 2:1 ratio, right? Because hydrogen is 2 atoms and water, oxygen will be 1. So any part of the world you go get any kind of water will always have 2:1 ratio. So that is law of constant proportion, because the proportion is constant. And when you talk about law of multiple proportion, when multiple elements are reacting in different ratios, they will be reacting, so the ratios will be whole number. That is law of multiple proportion, okay? So these are the three laws: law of conservation of mass, law of constant proportion, law of multiple proportion. So this is the definition I have attached here. You can see it, and that ends our chapter. So you need to practice the questions. If you comment down below, I will give you the questions, whoever is asking me. Because see, most of you may be thinking, why do I keep telling you to comment? Because that shows me the interest, and that also makes me interested in creating the videos. So I should know who is actually interested in learning from me, who is going to follow, who is watching the video till the end, and who is staying who's connected with me throughout the video. So if you comment down below, then I know you are interested.